All right, so this week what we're going to do is look at some more advanced unit elimination questions. The first one here involves some of the chemical chlorine trifluoride that was referenced in your lesson as being an extremely explosive chemical. What we're going to do in this question is we're going to try to convert the number of molecules of this chemical that are exploded in a theoretical reaction to the number of grams that were exploded. Now, in this case, there's no unit that converts directly from molecules to grams. So what we're going to have to do is do a multi-step unit elimination question. We're not just going to have to use one different ratio of values. We're going to have to use more than one. So we're going to have to track the units as we go through the question and hopefully eventually get to the unit that we actually want to calculate, which in this question is listed right here as grams. So I'm trying to figure out how many grams of chlorine trifluoride I have if I explode 5.62 times 10 to the 24 molecules of chlorine trifluoride. So as always with step one, what you want to do is write down all the values that you know with their units attached, which is going to make constructing the equation, which is step two, considerably easier. So I'm going to start by writing down the value that's given to me in the question here, which is 5.62 times 10 to the 24 molecules. And the minute I see the word molecules in a question, I know that they're going to have to deal with Avogadro's number. So I'm also going to put Avogadro's number down here. The third thing that I need to know is the molecular mass of chlorine trifluoride here. And I'm just going to magically make this appear on the page just to save us a bit of time. Abracadabra, there it is. The molar mass of chlorine trifluoride is right there. Now that I have all the information that I can possibly get from this question, it's time to form an equation. And hopefully I can get from my single unit value, which is molecules here. Right, as you can see, that's the only value I have in my list where the unit only comprises a single unit, which is just molecules, to eventually grams, which is what I'm trying to find. And as you guys know, the first step to these questions is to write down the unit that you're trying to calculate. So let's start with grams equals, and as you guys know, I'm going to always start with the single unit I have here, which is molecules. So I'm going to write down 5.62 times 10 to the 24 molecules. All right, so far so good. And then I'm going to multiply that by one of my values where molecules is the unit in the lower part of the fraction down here. Now, as you can see, particles, molecules, these are pretty much the same thing. You can essentially rewrite particles or atoms or molecules or cats or whatever you want here. So let's just change this. Look at that. As if magic, I've just replaced particles with molecules. Now, I want to put a fraction here where molecules is in the bottom. And as you can see here, molecules is attached to the 6.02 times 10 to the 23. So I'm going to have to put that in the bottom part of my fraction in the next part of my calculation. So 6.02 times 10 to the 23 molecules. And then the 1 mole ends up on top, right? Which is this part here. That mole here needs to still go into that fraction. So I'm going to just put it on the top. And of course, since there's no number on there, you can put a 1 in front of there. All right, let's move some of these dice off of here. Now, at this point, I can eliminate some of my units. So I know that molecules and molecules will eliminate. And then I can re-examine a question and see if I have the quantity that I want. In this case, the quantity I want is grams, but I'm currently with moles as my last remaining unit. So I need to multiply this by another thing. And that's what I mean by a multi-step unit elimination question. Multiplying by one ratio is not enough. In some of the questions, you have to multiply by multiple ratios. Moles doesn't get you there, so we're going to multiply that by something with moles in the bottom. And then that brings us to our very last value down here, the molar mass of chlorine trifluoride, which helps us convert from moles to grams. Now, I want to eliminate moles, so I'm going to put moles in the bottom of this fraction. So that's going to put a 1 mole in the bottom. Awesome. And then the 92.448 grams is going to stay on top. That'll eliminate these moles and these moles. Now the unit I have left is grams. And the unit that I wanted was grams. So I'm good to go. I'm ready to basically, as it says down here, math it up. Okay, I'm just going to take all the numbers, multiply and divide them. If they're in the bottom of a fraction, those numbers are going to be divided. If they're in the tops of a fraction, those numbers are going to be multiplied. And the first number is always going to be multiplied. So if I were to write this out, I would do 5.62 times 10 to the 24. And then I'm going to divide that by 6.02 times 10 to the 23. You'll notice I put brackets around this. And the only reason for that is because I need to make sure that both of these values end up divided instead of just one and then this one multiplied. I'm going to multiply that by 92.448. I'll do the math here and I'll put a copy of the solution I have onto the screen there for you to check out. But here is the magic that brings it to life. Abracadabra, there's the answer for you. As you can see, the numbers up there. I found out a way to put that into the scientific calculator on the computer where I'd use the bracket sign quite a bit. So it does work in there. To be honest, you're probably best to use just a calculator, a regular calculator that you can hold in your hand, which does the exponential notation considerably easier. But whatever you feel most comfortable with doing these calculations, just make sure you keep using that because whatever's easiest for you is going to work for me as well. All right, that's the first question. The next one is going to cover a little bit of stoichiometry. So get ready for ratios inside of chemical equations. We'll see you soon.